So, just to remind you guys, we're going to go on that field trip a little bit later. It's nice and cool outside. That's nice. Probably at the end of class, we'll go on a little field trip. You all right? Or some of us will. Sorry. Maybe I'll videotape it. So we'll go on a little field trip, see where the tutoring centers are, see what my office is, and all that kind of stuff. But what I want to do today is get into Chapter 2. I want to finish up Chapter 1, get a bit into Chapter 2, probably the first section, and then we'll head out on our field trip. I let us out a little bit early. Try not to get used to that. So last time, we sort of skipped Section 1-2 a little bit. We did all the beautiful definition stuff in 1-3. 1-3 is about stuff like parameter, statistic, all the different levels of the nominal, ordinal, integral, ratio stuff, right? Nobody had any questions for me, so I'm going to assume that's going fine. Section 1-4, where we talk about different ways to sample stuff. Cluster, stratify, systematic, all that kind of stuff. All right, I appreciate the looks, the blank looks. Wasn't that long ago? Yeah. All right. Okay, so is that decent? And there's just definitions. The first quiz that we're going to have, which will probably be next Wednesday, the first quiz we're going to have is going to be on all of Chapter 1, and it's just going to be, I never ask you to define something. So if I ever say, what's the parameter? Don't give me a definition. I probably told you a situation. A person goes out, wants to say something about all the gross 1 students, and he takes a sample. You guys kind of with me? I don't ask you just define this. I want you to use it correctly. So that's going to be the first quiz and a big part of the first test, right? Yes? Now, what I'm about to say, don't take this anything against what you just said. But if you ever have a math teacher who has Scantron graded quizzes and tests, they are not a math teacher. I am not sure what they are, but they are not. Because the most important thing with math is not even the answer. It's just how the hell did you get there, right? And yeah. So sorry, I don't. I'm glad you brought that up. So definitely don't get Scantrons for me. I don't want to see them. It would be my job would be so easy. Trust me, it's very tempting. If I had kids and stuff, maybe I'd be doing that, or forcing you guys to do online homework. But I don't have kids, so hey, I got time. All right. So let me see. So I want to get back, do 1-2, finish that up a little bit, and then get into Chapter 2. So one big thing with Section 1-2, it actually, part of what we talk about in Section 1-2, it comes back to us finally in Chapter 10, which is kind of funky. But one huge thing with statistics is something called correlation. I don't know if anybody's ever heard of correlation. So, what was it? There was something about a comic I saw once that said, we found a correlation between the number of cats you have and the number of times lightning strikes your house, something like that. So you could find funky correlations between two sets of data. So I could say that if I go watch people playing basketball, and there's a correlation between people playing, let's say, professional basketball and the height of those people, right? Obviously. You have outliers, like this is going back a ways, but Spud Webb, for example, always gave me hope, because I played a lot of basketball when I was younger, and then I hit this height, and I stopped. I'm like, oh, shit. So that was out of my dreams. But is that cool? Do you guys agree with me? In the word correlation, you understand that one thing kind of relates to the other thing. So height and playing basketball are correlated. How are we doing so far? Drinking beer the night before test and the grade you make on the test might be somewhat correlated. You guys kind of with me? Now, of course, there's a lot of other little factors. We're going to get a lot deeper into it. But the main thing we need to realize in this section, what it tries to get across is, if you made the assumption, if you're watching the basketball game and you say, very interesting, so playing basketball makes you taller, interesting, all right. Of course, that's complete silly crap, right? What's the correct conclusion to that observation? Observing that there's a correlation between height and people playing basketball. What's the correct conclusion?
People who are tall are more likely to play basketball.
Exactly. If you're tall, you're more likely to play basketball. You're more likely to be able to play basketball against other freaking tall-ass people. Right? You kind of with me? All right. So that's a very silly example, but there's so many examples of that. I'm so worried about, like, trying to correlate the type of student you are and the grade that you get. And to me, there's something there, but there's also something not there. You can't... the college I used to work at, I actually did a lot of the research analysis for them. And they wanted me to say, who's the average student who comes here, and who are the ones that do best? And what I was worried about was they were only going to start accepting the students that I found in my study. And I'm like, that's shit. I want you to realize, you got to be careful. You can't close the door on people just because this is the average student that does really well. So you don't want to take correlation too far. So the problem is this. Correlation does not imply causation. So just because two things are correlated does not mean necessarily that one of them causes the other one. Here's another silly example. I sell ice cream, and next to me, you sell water, right? And that's exactly how I say water. So let's just all get over it. I don't even realize it was a weird way to say it until I said it, and students started laughing. Oh, what's the matter? And I notice when people buy more of your high-quality H2O, they happen to buy more of my ice cream. So I'm like, oh, so buying water makes people want to buy ice cream. And of course, that's bullshit, right? What's the actual conclusion? What's probably happening behind the scenes there? When water sales increase, so do my ice cream sales. So then I go, let me go try to get people to buy your water, because then they're going to want to go buy my ice cream. You guys kind of with me? What's actually happening?
Ice cream makes you thirsty.
Maybe. When do people buy more water? And what do people probably do then also? So there's a third variable that affects both of them. Do you guys see that? So just because you see a relationship between two variables, when this one increases, so does that one, it doesn't mean that this makes that one go up or the other way around. It might even be a third guy that makes them both increase. Kind of with me? And now, and you got to, and there's so many studies now are done to see how to improve the economy, to see how to, and if you just see the economy went up, at the same time that we restricted broadband usage or something, like, let's restrict it more, and then the economy's going to go up even higher, and that's, no, they could have just happened at the same time coincidentally. Or there could be something else that happened that made them both change. You guys kind of working? All right, and that's one of the most heinous misuses of statistics today, is misinterpreting correlation. Okay, so that's one little thing out here. And they're going to have silly examples like that basketball example. That was exactly the problem in the old textbook. The basketball makes you grow taller. Oh, I shot a hoop and ooh, there I go. No, unfortunately not. Okay, another little piece out of the section 1-2 is, we sort of talked about this a little bit, voluntary response samples. Somebody said something to this effect the other day, but just looking at the name, can you tell what it means? What type of sample would this be? What's true about the people that are in that sample? They volunteered. So, for example, I sent out a survey to all Grossmont students, all 20,000 some odd Grossmont students, and 8,000 sent it back, and that's pretty good. But what's probably true? Like you have there's a talk show on, and you have phone lines open for people to call in with your opinions. No, let's talk about talk radio. This is a good one. Who are the people that are calling in? They're volunteering to call in and give their opinion, right? What's true about these people most likely?
They're all listeners.
All right, so they're a bad sample in that respect. But what else is probably true about these people?
So they strongly identify with the person that's conducting the survey.
All right, they have some strong identification with something that's going on, right?
They're the ones picking who.
Yeah, they're self-selecting, right? And I think that's what you're saying. But here's the thing. It's sort of like what you said. They almost always have some kind of a bias. They almost always have a strong opinion in a very extreme direction. You guys kind of with me? So not very often will you get people that are content speak up. So if you see like a lot of people complaining about a certain airline, maybe they're the assholes that would never be happy. And everybody else is kind of like, they're not, it was nice. I'm not going to write in about it. It was fine. So it kind of ends up looking like it's a horrible airline. I don't want to go on there. Oh my God. Right? But it skewed the results because they self-selected to actually say something about the airline. So they must have had a strong opinion about it. Something that actually made them want to do that. So it's not saying that every single voluntary response sample is bad. It's saying that I cannot trust any of them because they wouldn't be random, for one thing. And for another thing, they probably have some kind of inherent bias that's going to skew my results. It's going to make me think the wrong thing. How are we doing so far? All right. I think I over-talked that one. That's all right. These things happen. Blah, 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 blah. All right. And I'm going to let you guys, you just got to get in there and try the homework out. Some of the stuff in section 1, 2 is sort of common sense kind of stuff, but you just got to get in there, try it out, and see, and let me know if you have questions about it. 1.3 we talked about already. 1.4 we talked about. So that's chapter 1. All right. So like I told you earlier, I was going to go through chapter 1 pretty quickly, and I did. There you go. All right. So any questions before we leave chapter 1? Any questions from chapter 1? Can you guys do me an example and close those doors for me? Thanks, man. There you go. Cool. Just in case we have random people coming by. Yeah, sorry. I set you up for that. That door is freaky. All right. So, I want to show you guys something. This is really neat. Get a workout. Let's see if both of these work. Let's see if either one of them works. Yeah. There it is. Look at that. You can almost see it. It's coming. Yeah. So I want to show you a picture of a completed a problem that you could see in section 2.2 and 2.3. Let me tell you this right now. You might want to write this down somewhere. When you go to do section 2.2 and 2.3 homework, you almost want to do them together. Because 2.3 homework is going to reference stuff that you did in 2.2. So if you turn in 2.2 homework and then go to do 2.3, you're like, oh shit. Because it's going to tell you, using what you did for 2.2, now make this kind of a picture. Right? Let's see if it gets any brighter. I have control over lights here somewhere. Way too many things. Oh, can you guys see that well enough? I actually took this straight off of 25 of you have filled out that survey. One of you filled it out 6 times, which is neat. All the same data was up there 6 times, so I just got to delete it sometime. So don't forget, you got to do the survey for me by Monday, because I like to create quizzes and stuff out of it. So do that for me. So I took the 25 people who fill it in. I took the mom's heights and the dad's heights, and I put them all together. And now they're just people's heights, right? And I made this picture. This picture is called Histogram. Can you all see it well enough? Is that all right? So it's heights of parents of Math 160 students. So that axis here is kind of weird maybe. It says relative frequency, but maybe you could figure out what that really means, right, in English. This is in statistic-ish. Can somebody think about this for a second? What does this mean down here, these numbers, specifically, and the heights of these bars? What do they mean? Good, all right, so inches. I should have put that's one thing I left out was the units. Somebody put centimeters down there for me, and thankfully I'm a math guy, so I could convert it pretty easily. But being more specific, 55, and how tall is it? About 4, right? So, what do you think that means?
Inches by how many people are in that?
So being very specific, 4, maybe 4 people. It's not quite right, but we don't know yet. 4 people, 4 people's parents
Size 55.
were around 55 inches tall. So 55 inches is the midpoint. Now think about this. You guys can look at that one over there. I'm not going to run them. How wide is this, what we call class? This is one class. What do you think these edges are from what to what? How far apart are these midpoints? They're 5 apart, right? So how far apart do you think these are? Maybe 5, right? So think about this. What would those be then? If that's 5 wide, how far away from the midpoint do you go out? 2.5. So what would that be? That would be from 52.5 up to 57.5. And then this would be from 57.5 up to 62.5. You guys see how that kind of goes right into play? It just goes right over top of each other. It makes sense. Are you guys kind of with me? This is the first time I've taught it this way, by the way. I thought it would be a good idea to show you a finished product. See if you can interpret what the hell's going on with it, and then maybe that'll help you make your own. Because you're going to make this kind of image a few times over in your 2, 2, 2, 3 homework. So chapter 2 is all about, chapter 1 is about the words we use and then how to collect samples. And we're not even talking about analyzing. Chapter 3 is where we really start to sink our teeth into finding the mean, finding the median, finding percentiles, actually analyzing our data. 1 and 2 are all about talking about data and then representing unanalyzed data, right? I just saw this. How we doing so far? All right. Let's see, what else can I say about it? So what this turns out to be, this relative, if it was frequency, it would actually, that would mean that 4 people, 4 parents were around 55 inches tall, between 52.5 and 57.5 inches tall. Are you guys with me? That's that first class. But the relative word makes it into a percentage. So 4% of the people's parents I saw were around 55 inches tall. Without that relative word, it's pure numbers. Relative means relative to the total. So if there were 2 out of 50, which is what it was, that's 4%. So that's the relative to the total. Okay, good. I like it. I like it. All right, so let's do some data of our own. So here is, I'll probably blow this one up. Hey, look at all the numbers. Woohoo! All right. Where did I put you? There you are. So what we're going to do is, we're going to first try to organize this into a table. That hurts. I remember that. Try to organize this into a table so that we can make a histogram from it pretty easily. So what we want to do is set up what our classes are, count how many people actually go into that class, and then we could probably make the step into 2, 3 and actually make the picture, right? So the first thing we got to realize, the first thing we got to figure out is how wide do we want our classes to be? So the width will change. What do you think? Let me see if I can do this without hurting. What do you think is it that would tell me how wide I want my classes to be? Why would these 5 wide, maybe? How many classes are there up here in my histogram?
5.
Yeah, there's 5 classes, right? If I had picked more classes, would they have been as wide? No. So the width is somehow related to the number of rectangles I want to use, right? The classes. And it's also got to be related to what else? how wide my data set is, right? If it went from 55 up to 100, I don't want to meet that 100-inch tall person. But if it did, they'd have to be wider if I just wanted to use 5 classes. Are you guys still with me? All right. I want you to realize, and the math behind this is pretty simple, and I'm going to try to make it something very physical that you can actually feel like you're doing something. Here's my stupid example. You ready? Let's see. Let's pretend like I wanted to, screw it, and you've done it. I just go crazy, and I want to put wood paneling up here. Right? Maybe it's a wood paneling class, and I just want to put wood paneling up here. And I want them to have the same width, all my panels. So I want to cover this board here with wood paneling. And let's say I want to do, oh, look at this. No way. I can almost make this official. 100, 200. Sure, we'll say 250 just to make it something nice. So let's say this is 250 centimeters across. Right? So this is position 0, and this is position 250. And I want to cover this with wood panels, and I want to use 6 wood panels. So if I want to use 6 wood panels, so that's my physical. Can you see the wood panel in your mind? You can see the wood panel. You're like, why are you doing this, Jeff? And then you put the wood panel up here. And I want them all to have the same width, just like my classes would. Right? So this is related to my classes, my rectangles. And I have to cover 250 centimeters worth of space here, of length. Right? So how wide would each panel have to be? Exactly, right? The math, hopefully, now that I've made this a more physical problem, is pretty damn simple. And and I'm talking a lot about it, but 250 divided by 6, of course, right? You're going to divvy up the 250 amongst each of the 6 panels. And what is that roughly?
41.66.
Yeah, this is about 41.66. And if I wanted to make sure that I covered this thing, the most important thing is that I cover entirely this board. I would probably just go ahead and round that up to 42, right? Would I ever round down? Because if I round down, what's going to happen? I'm not going to be able to cover the entire thing, right? And that's exactly what I want to happen up here. If I didn't make my rectangles wide enough, they would leave some of the data out at the end. That would be weird. Those poor people just fall off at the end. Okay. All right. So let's do some actual math here. So what I want you to do, don't say anything out loud. Just take a minute. And I want you to figure out. So this thing we just figured out here would be our width of our panels. But for us, statistically, this is called the class width. Now let's make this formula a little more formal. So that's 250. So class width. Where did that 250 come from? Good. It was like 250 minus 0, right? So what would the width be? What would go on the top from that data there? What would you have to do? Yeah, the largest. See how nice that was? On Monday, by the way, I'm going to bring some calculators with me, but I don't have one for everybody. So if you're going to get a calculator, get it soon. Monday, I'm going to show you how to put a large data set in and get it to sort. It's kind of important for this, is to get it sorted. I gave it to us sorted today, so we can just get to it. So on the top of this would go 75 minus 60. This is something that's called the range. The range of my data. How far my data ranges. That kind of makes sense. And on the bottom it's going to go what? Where did that 6 come from? Good, the number of classes. And normally, depending how large our sample is, we use 5 to 10. For us, we're probably never going to have to use more than 8. Right? So if you have a very small sample size like we do there, you want to use 5, maybe 6. The bigger it gets, use 7, 8. There's an actual formula that uses logarithms that we're not going to use. Right? We just kind of eyeball it. If you used 10 classes on that, I would have to take some kind of points off. That's just a small little thing. So the number of classes would go there. This is normally from 5 to 10. So let's use 5. So I got 75 minus 60. We'll use 5 classes here. So what's that come out to be? 3. Correct. Cool. Okay. All right. So how does this get set up then? This is not wood paneling. I can't actually cover this data with pieces of wood. So here's the weird part about classes. I'm going to show you a couple ways to do it. I'm going to show you the textbook method first, because you've got the textbook then to kind of back yourself up. I'm going to show you the way that I was taught, which people don't like sometimes because it uses inequalities and it uses x's and stuff. Right? Of course, I always have to have something like that. But you'll see what's weird about the book way here in a second. So where do you think I want to start? I want the first class to start where? Probably 60. You could use anything like 58, 59, 60, somewhere. But normally you try to start it right at the first data point. So the classes. So where do you want the next class to start? This is going to be 60 up to something. Where should the next class start?
65.
Yeah, 60. Well, no. Yeah, 63, right? Because how far away should the next class be? 63, because our width is 3, right? So tell me this. If this next class starts at 63, I want you to... Why is it wrong to put a 63 there? Because then where would 63 go? Yeah, and that sucks. You don't want to double count anybody. You're like, you count twice. No, right? So you have to make this 62. So the true class width, you can see them between these numbers, not between these numbers. All right, stay with me now. The textbook method has a little bit of ambiguity. My method doesn't. Just deal with it. So what would this be? Good. So you can always see 3 up and down here. It's going to be 2 across. This will be 66, 69. This will be 68, 71. This will be 2.
5.
Yeah, it would be 74 officially, right?
Yeah.
This is the one time. I'm kind of glad this, and I made it happen. I won't say otherwise. But actually, it just happened. That's the data. This is the one time you're allowed to change the last class. Is when? What's the last data point?
75.
All right, good. So they have to have the same width. They must have the same width. This does not have to be the last data point. The last data point just has to have a place to go. Do we currently have a place for our last data point to go?
Yeah.
So we can do. We do. I like that. You're like, gosh, they can go home. Leave it out. But see, I only have a place up to 74. How many classes do I have? 5. The number that I wanted to have. So I could make one more class just for that last damn little data point. Or what's normally done is you just make this last number, just suck that last data point in. Right? That's the only time you're allowed to change the width. All right, cool. I like it. I love it. So many guys look like, this is so exciting. Yes?
What if it was 76 instead of 75?
If it was 76, this would have been different. It would have. It's kind of funny. Once you started to pull it away a little bit more, it would have been captured by this. Because right here, if this would have come out to be 3.1, you would round up to 4. You always have to round up. Because like we said earlier with the paneling, you have to make sure you cover it. You can over-cover it, but you have to make sure you cover it. Right? So since our last data point is 75, this has to be at least a 75. It could have been 78. We could over-cover it, but it just has to have a place to go. Cool. I like it. All right. So now we just start counting. I just want now to get my frequency. How frequently does data show up in each of these classes? So between 60 and 62, how frequently do we see a data point? How many data points are there? From 60 to 62? 4. Yeah, 60, 61, 62, 62. So there's 4 data points there. Keep going. Finish that out real quick. Yeah, so the next one is going to be 4. 66 to 68. Okay. And then 69 to 71. 3, cool. And then the rest must be there. 5, cool. And what's a really good idea? How many total data points do I have up there? Yeah, so I should have 25. And does this add up to be 25? Yes. So do that. Do that at least, right? If you add this up and you get 24, you left somebody out. That kind of sucks, because then it's going to, you have to almost have to do it all over again to see who you left out. You with me? If it adds up to 26, that's neat. You have created a person, right? Not in the normal way. Okay, cool. So that's not bad so far, right? That's basically how you attack some list of data that we have. One of the easiest, quickest, nicest ways to kind of present it to somebody is to make a histogram out of it. And this is how you do it. Now notice how much flexibility there was here. Did we have to start at 60? No. We could have started at 59, 58, something around 60, right? Did we have to use 5 classes? No. We could have used 6 classes. Could you have used 4 classes? What was the number of classes from 5 to 10? So if you use 4 classes, you will lose points. It has to be at least 5 classes. Cool. All right. So how do I make relative frequency out of this? Now that you know what relative frequency means, how would you make this into relative frequency? A real frequency.
Take the frequency number and then divide it over how many there are.
Yeah, so there's 25 data points, right? So what percentage of the data points are here? 4 out of 25. And 4 out of 25 is what percent? Hopefully you guys remember, if you make the bottom 100, the top is the percentage, right? So you just got to multiply this by 4 to make it out of 100. Is that cool? Or just divide it in your calculator, get 0.16, move the decimal over a couple times. So this is 16%. So this will be amazingly enough 16%. This will be 36%. 12%. And what's another quick check you could do there? Add them up and make sure they add up to be around 100, because you might have to round these sometimes, right? Or 25 was nice. What if the bottom was 37? I'm not writing all that freaking decimal points out. I'm going to have to round. But they have to add up to something like from 99 to 101%, somewhere in there. If it adds up to 95%, no. You left somebody out. Poor little dude. All right. How we doing so far? So this shouldn't be too taxing, but I want to make sure everybody's on the same page with me. This isn't too horrible. Okay, so there's a couple of weird things to talk about now. If I try to graph this right now, the first bar would be from 60 to 62, but what's immediately a problem? Where would the next bar go? So if I try to start graphing this thing, this is where this room is going to be a problem. Let's see. If I try to start graphing this thing right now, holy crap. It's like a magic trick, all right. If I try to start graphing this thing, that would be 60. And it would be a bar over to 62. And where would the next bar start? 63. And what do you think a gap, so it would look something like that maybe? What do you think this would tell people? That there's nobody in there somehow, right? So there can't be gaps in your histogram unless you actually have a 0 somewhere, right? That's the only legitimate place you can have no bar. So that's the problem with the book's method. That's the problem with the books method. These are what's called the class boundaries. Sorry, class limits. I'm thinking ahead. And what's outside of here are the boundaries. This is why I like my method better. And it's sort of like there's the limit of me, right? I stop right there. That's the stop of me right there. But if you're standing too close to me, I'll be like, get out. You're in my boundary. You're in my personal boundary. Get away from me. Does that kind of make sense? So these are the limits. This is really where this is. But then on the edges from 59.5 up to 62.5, those are called the class boundaries. So these are the limits, and these are called the class boundaries. Does that sound familiar? This is one reason why I liked doing this thing earlier. Remember what we said about this? Wasn't this 52.5 up to 57.5? Those were that class's boundaries, right? So we're running into the same problem. Right now, we have to create them ourselves. So when I go to graph this, I actually have to use these numbers to show where those rectangles are. Or you could just use the midpoint. What would the midpoint be here? 61. Yay. Either way, you have to understand what boundaries are. Some of the problems in the homework talk about boundaries, right? But you can certainly use the midpoint as like I did when I made my histogram. So if I go to make this, I really should make it, the scale should start at 59.5, and then it would be 62.5. And where's the next class start? What's this guy right here? See, so now there's going to be no gap. They go right on top of each other, right? That would be 62.5 up to 65.5. And now do you see how far apart are these? 3. Now you can really see the class width. It was kind of hidden because you couldn't see the boundaries. Or maybe. Okay. 65.5. And then you just go up by 3. 68.5, 71.5, 74.5. Precisely. And then 70. I'm sorry. Oh yeah, that's the. I got there. That's right. The last one we put up by 1, right, to suck that 75 in. Cool. So let me. We'll go ahead and draw the picture, and then I'll tell you the other method, my method to do that, the way I was taught. What do I put on the scale here? I didn't tell you yet, right? So you have to be careful. Sometimes I'm going to ask you to make a frequency histogram, and sometimes I'm going to ask you to make a relative frequency histogram. The funny thing is, would the image ever look different? No, the bars are going to be the same relative height compared to the other bars, right? But this just makes more sense to us as humans. That's why we created percentages. If I say 4 out of 29 people like me, I say, no, what percentage is that? I can kind of wrap my head better around the percentage. True? So if I want to make a relative frequency histogram, what scale should I use here?
0 to 40.
Yeah, I love it. So I got to make sure I get up to 36. Cool. So I may have to go up to 40. So maybe I could use... what do you have? 5, 10, 15, 20, 25, 30, 35, 40? You don't have to count like that. Yay. So just make your scale so that it makes sense. It has to be consistent. The quickest way to make me cry, besides cheating, is to say 5, 10, 11, 30. So it's got to be consistent. Just got to be able to find the largest one in there. And now it's just simply make the bars as tall as their percentages are, right? So this would be, where'd it go? 16, roughly right there. It's funny, I'm trying to be nice and precise, and my scale is so crappy. And this is 16 again, 36. Hopefully when you make yours, the rectangles be a little bit more close in width. 12 and 20. Cool. Sweet. Now, if you use midpoints, you could just put here 61, so forth, right? Okay. So real quick, the method, the way that I was taught, works like this. Let me put it up here next to this one. So the way I was taught goes like this. My first class would have been 60 to 63. So immediately I've lost like 10 people. I'm not going to do that shit. But do you see how, does anybody see how this is cool on two levels? I can see the width in every one of my classes immediately, right? And where does 63 go? In the first one or the second one? Because 63 is allowed to be here. It's not allowed to equal 63 there, right? So my class boundaries are exactly the same thing as my class limits. They're the same. So it's like I wouldn't be upset until you like touch me. Do it. Right? My boundary's really in there. It's not reality. Don't test that out. And so forth. Right? So you can do either way you want to. This is the way they talk about in the book. So you can do it that way if you like the book to kind of back you up. Or you can do it this way, and then what kicks ass here also is, when I go to graph it, it would just be 60, 63, so forth, right? I don't have to use these weird-ass half-off numbers. So, trust me, if you want to do it this way, I'm not going to hold it against you, right? I'm not going to favor the people that, oh, use my way, oh, I'm going to give you some point. I don't care which way you use, as long as it makes sense to you. Okay? Cool, maybe. Yes, ma'am.
I still kind of I don't understand your way.
Yeah.
That's fine. No, if you don't understand this,
Yeah,
don't do it.
I want to. Yeah.
Well, that's it. So from the very beginning, when we first got the width was 3. Watch. When we first got the width was 3. Remember how I had to do this for that way? And then go, this has got to be a 62. No, I can just go straight and say my first class is going to have all the numbers that are from 60. So what am I going to use in this first class? All the numbers, because what does X represent? All the numbers. All the numbers that are between 60 and 63, not including 63. So when we went to make this first thing, we didn't have that there. I said, okay, 63 there, so you can see that's 3 apart, right? And we couldn't put a 63 there, because then it would go on both. So we had to make this a 62 and do all this weird shit, right? But here, I can go 60, 63, because now I'm saying, no, don't go all the way to 63. And what's really extra cool, we didn't even talk about, what if your data has decimals in it? So if my data was like 60.6, 61.7, you would actually have to make your limits to be something like 60.0 up to 62.0. Or, whatever you have to do, 63.0. And then your limits would be 62.05. I mean, it just gets weird. Right? So I with this one, decimals, all the decimals are captured, right? Where would 62.9999994 go? There? Because it's not quite 63 yet? Yeah. But again, trust me, please. If that still doesn't make much sense, you do not have to use this. This is in the book. It's fully explained in the book. You can do it this way. That's fine. Yeah.
So will your intervals change when you're graphing it?
What's up?
Will your intervals change?
Yeah, so this would be 60, 63, 66.
Well, how will you show that though? That's the problem. You said that when you're looking at it, we'll make the 60 right? If it's in the line. So how will you show that?
No. Because you've defined this.
Oh, yeah. Okay.
Yeah.
Okay.
Got it. Yeah, so that's got to be a part of what you... That's section 2.2 is where you make that table. And then section 2.3 is now make the histogram off of that. Both of them together makes your answer. Yeah.
So if you were to make the classes like the book, you would use that on the histogram. And if you, that one.
Yeah.
And if you were to use your way, we would use the bar.
Yeah. Yes.
But what about the last number? Like 75?
Same thing. So the nice thing is, so the last thing would be, normally would be this for my method, and I just go there. That's all. Yeah.
So basically on the test, we just have to either write your way or the other way, and then you'll look in a graph if it matches up.
Yeah.
But we have to like sit there and say like, this is the way we chose to do it.
Well, I'll see it when you set up your classes. I'll see which way you chose to do it. The mistake people make is they do a little bit of both, and that's never good. Completely pick one way or the other, right? Don't do parts of both. That sucks. Things get weird. All right. Maybe. Nothing too evil. I always have to find a way to make it weird. I wish books would stop teaching this way. I really wish they would. It's the only reason I even show you this. And I know some of you guys don't like this, but if they taught it this way, then I would more fully explain this way. But this is just, if you this makes sense, use this. If it doesn't really, don't. Just go ahead and use that. The book's got it in there.
For your method, would you use, so it would be like 60 to 63, and then the next one would be 63 to 66, the next one would be 66 to 69?
Yeah.
So you just need 5 of those, and then you can just graph it?
Yep.
Because originally you're just adding 3, right?
Yeah, I'm still adding 3, but the beautiful thing, I'm adding 3 that way and that way. Because it doesn't overlap because this doesn't have the equal sign.
And then one other question, how do I remember you said that you can stop, well, because we stop at the highest number for 75, and then the last one you just draw the line underneath it.
Yep, cool. Because here you would normally put a 74, so you just made it go up to 75. This one, I normally would say less than 75, and now I just go, yeah, come on then. Let's make it equal 75, yeah, cool. I like it, sort of. Make sure one of those methods makes sense. If neither one makes sense, come see me. Let me go ahead and let you guys, I'm going to make up some data, put it up on the board, because I went through that a little faster than I thought I would, so hopefully you guys are okay. I want to make sure. Monday I'll have a little handout with some data from hopefully the surveys you're going to fill out over the weekend for you to create some more histograms about yourselves. So let me make up some data right now for you guys to make a histogram out of. So I want you to create a relative frequency histogram for this data. I just want to remind you, if you calculate your class width, if it comes out to anything that's not a whole number, you round up. Dear God, don't try to use 4.1 as your class width, right? If you get 4.1, round it up to 5. You always round up. That's me trying to write really well, by the way. So hopefully... I'm surprised that anybody's left after seeing how I write. So I'm glad you see this. So do everything we just did. Make a relative frequency table, and then make a histogram out of that. Whichever way you want to do. My way, the book way. Let's do this just so it's easier when I do this problem for us all to compare. Let's all use 5 classes. If you use 6 classes here, I'd be okay. If you use 8 classes here, no way. This is a very small sample, so go ahead and use 5 classes. So many guys are like, dude, say that sooner. Too damn bad. Use 5 classes. Oh, I see why you want to use 6. It's too bad. Aww. I want you to get practice with if it comes out to not a whole number. Yeah. Those math people and the rounding. Use 5. You suck, Jeff. Too bad. Use 5. make sure everybody's on the right track. When you do the division, what do you get? 7.2. So what class width are you going to use? Beautiful. Kick ass. You use 8. Round up.
Started from the highest number. So you subtract them, but I don't know what do you get the what's it? 40%? Yeah, 40. I don't have my calculator. Well, how much is 36? Oh, so it's 36 something. Divided by 5, right? Oh, it's 7.2. So they round it off to 8.
Okay, cool. All right. So this is the book.
Then sitting here. So that's going to be the observable. You start with the number starting with 7. Yes, so there's 360. So there's 3 in third. So 8 observable, right? From 7.
So see, your width is 8.
So that would be
I would say, I need you to do this for me. We want this to be a 15. You just can't do it because in my way, it could be a 15. Yes, good. You can truly add 8 everywhere. Don't even do that. Good. Because it's in the book, right? I have to. It's in the book. People will.
What's like whole percentage?
No. The last number doesn't have to be the same. It has to be the right width. So you don't care. As long as the last one is data point has a place to go.
Just gotta make sure it adds each other.
40. Only get 4 though. 4 classes.
Well, then it would
Not too bad. How many classes?
this would just have to be one less.
Oh.
So that 15 has a single
Then you
place.
got it. Yeah, you got it right. 7 to 4.
So the 14 and a half. And this would go
So
down.
you go from the top of the 8 interval instead of 7. That's that. So that's you got that time.
Oh, here.
Oh my god!
So now you can go ahead and
How do you find the frequency? I didn't understand that one.
The frequency is, this is your regular classes, right? So anything that falls in this number, this one and this, so you look at your data. The 7, that falls between this and this. You look for that. 3, okay. So that's your frequency.
You always round up to 8.
But 15 is not here, so you just
Say you count, yeah. So anything from 15 to 24, there's only what you got like 17, right? 17, and 18, and 54. Got it? So you got how many
You're
are?
going to do it my way.
oh, like count the 30? If it's the 30.
Yeah, if it goes under, yeah. So these are 31. So anything to 30.
I know. Until he sees it, he's like, oh.
Oh, yes. And then the other thing is,
And then divide by 5, right?
More straightforward.
Yeah, like what is the total number of, I mean, the 25, 1, 2, 3, 4.
Like, I don't understand.
How many numbers do you have? No, you have to look at your sum. So basically you divide. If there's 17 out of, 4 out of 17, that's how you divide it. That's your first.
But it would be 3 out of 17.
Yeah, 3 over 17. So whatever that is, you multiply by 100 versus the relative.
yeah, if it's not a whole number, you're your width would be.
So you just from 0 to not including how
Normally you start with that.
Get it?
So 7 over 17
Times 100. Yeah, that's 17.6. Yeah, that's your first one. So you just keep going.
your first visit is it's Tuesday, Thursday.
Because you started from 0 and it's with you. You don't want to start all the way down there.
It's probably wrong enough. You have that. Just add it up to the total of 100.
Good. And then it depends on which way you want to do it.
So add it up. Is it 100 altogether?
Yeah, I know.
Oh, the first one. 17, no, this one. 17.6 times 7.6 plus 41. And then you make a 99.7. Yeah, that's fine. It's close to 100 because you only go up to 1 decimal here. Jump somewhere along the way, but it's close. So then you have to make a graph. 5 is what's your range?
Yeah, they're like,
Is there?
Do I have to go down?
way more simple.
No, because if you're numbering here, you don't have to you go by your data. So your lowest score is 7, right? So you can go probably at 6.5.
Yes.
How wide you figure out how wide you are. 8 wide. So if you start the first class at 7, next class
So,
8 there. And then of course, where the class is ending, I don't know which method you want to use. Okay,
14.
and then you want to next person that moves 14.
Yeah.
And then 15.
Yeah, so to 14.5. Because anything that falls between there, you drop it.
Oh, okay. We're going to do it here together in a minute, but it looks like... Yeah, okay. Yeah. And then when you add it, it might not come up to the exact. Yeah, it adds up to the right number, right?
Yeah, no, that's annoying. Hated doing that.
These guys have been waiting for long.
I'm glad you did really good. Still have it.
I was actually telling her that she got around so bad.
But I guess it makes sense. Yeah.
I mean, it makes sense when you do put more correlation during the test ground. But I mean, I wouldn't want to risk that. It's a pretty significant jump.
That was really round. Yeah, round up to make sure we cover.
Yeah, I know.
Differential equation.
I might see.
You can take all four of them.
Check to Irvine, but I want to go to I don't see me. Last semester, I had to check my name.
Yeah, I'm taking my last one. I placed pretty good, so awesome. Right now, I'm taking
I did my own before.
You're finding these teachers.
She was a hippie, so we
And on the ends of the file, he's like, I'll just assume everyone did all the homework and just give me
But I'm trying to graph it. You couldn't get the graph yet? Ah, you graph.
Oh, I see. That was pretty.
Try starting next
Yeah. That was pretty crazy because when I took 120 last semester, I had like a crazy level.
What's your first
And then now I have like a.
I took 120
Because I got 1, 2, 3, 4, 5, 5. What's your first and 57? So you would have
I had to deal with it. And then now.
my job is he's like,
I didn't take them seriously. And that was, by the end of it, we were like 7. Not even kidding. So night class 2.
he knows how to figure out
Alright. Woo! Let's do this together. That was exciting. Alright, let me see if I have room up here. So, try to do it both ways here. It shouldn't change your counts. So when you do the class width, we got 7.2. So you go up to 8 for the class width. So I made sure everybody was on the right track to begin with. You do have flexibility in where you start, but you pretty much always start at the first data point, unless your class width was 10 and the first data point was 41. I'm going to start at freaking 40, so then I can go 40, 50, 60, 70, yay, right? That's almost the only reason you would ever not start at the first data point, is if your width works better before that. So I'm going to start at 7. My width is 8, who cares? You guys kind of with me? Alright, there's absolutely no reason to start at 0, because then the first class would barely catch anything. It would almost not need to exist. So if I start at 7, if I do it the textbook way, the next class should start at 15. Right? And this is my way too, it would do the same thing. But now the textbook way would have what number here? 14. And then you just add 8. So once you get this started, you just keep adding 8 on each side. 23, 31, 39. Add 8, 30, 38. This number does not have to equal the last data point. That would be really, really hard to do. Right? It might just happen just naturally, but if it doesn't, who cares? As long as that last data point has a place to go. That's all I care about. So if that was 42, that's where I have to make it go up to 43 to suck that last dude in, right? But he's got a home. He's got a place to go. It's right here.
Would it be wrong if we just kept it at 43?
Yes. Because then your rectangles, would they be all as wide as each other? No. So that's what's most important here, is you have to be honest when you make a histogram. You have to be honest with how you're representing it. And the only thing you're allowed to do is suck that last data point in. And that's when you can make it a little bit wider than it's supposed to be. If you did it my way, then, try not to break into song here. This first one would be, this would go from 7 to 15, and then 15, 23, so forth. So you could actually see the width both directions, right? Yes?
So the difference between yours and the book way is yours will end on 47 and the books would end on 46, right?
Yeah, and actually visually it would end at 46 and a half, right? Yeah. But yeah, you're right.
Okay.
Yeah. Cool. And so we might as well talk about that real quick. What would the boundaries be? 6 and a half, 14 and a half, 14 and a half, so forth, all the way up to 46 and a half, like we said, right? Now, yes?
So if you really don't have to worry about like knowing the what is it called, the boundaries, like you don't have to worry about like calculating that or whatever, because you can, right?
If you do it this way, the boundaries are the limits.
Okay.
They're the same.
Okay.
Yeah. But some of the homework has you reference histograms that were made using this method. So you still have to understand what boundaries are and what they represent. But when you make your own histograms, if you do it this way, you don't have to use the boundaries. They are these. That's beautiful, right?
Okay, wait, but how you? I don't get how to find class boundaries. Did you say you like?
So watch this. Here we go. Let me focus on this for a second, because when it's decimals, it's a little weird. So let me just focus on boundaries for a second. Right, appropriate in a geography classroom, I guess. So if I have whole numbers, like if it was 17 to 21 and so forth, then the boundaries would just be off by exactly a half. You with me? If I have, because this is, if I add a decimal to this, isn't that 170? I can kind of look at it like it's 170 if I ignore the decimal. So then I go down to 165. This would go up to 215. All right, now, stay with me now. So it's always off by a half, but based on the decimal place you're at. And now you start to see why I wish they would let this go. But what if I had my limits were like 7.12 to 8.39, right? So then your boundary here would actually be, if this is, I really want you to understand. Let me just show you what it is and see if you understand. This would be 7.115. It's half off from 12. What's half below 12? 11 and a half. Do you see that? So it's got to be in one more decimal point over. So if that's 17, we went to 16 and a half, one more decimal place over. If this is 7.12, I better go one more decimal place over for my down by a half. And again, that's an advantage this way has because it includes all possible decimals in it already. I don't have to worry about shit like that. And I'm not trying to make you, if you really don't like this method, I'm not trying to make you feel bad that you have to use this method, right? But I want you to understand that this method has something you have to be careful about. The boundaries are one thing, how to calculate them. What would the boundary be over there? This one's easier.
8.395.
Yeah, so adding is always easier. And this would be 8.40. So then this boundary would be, what's half below 40? Half below 40 would be 39 and a half, right? So it'd be 395. Do you see that? And so forth. So, and these match, which is exactly what boundaries are for, so that there's no gaps between my bars. Okay, cool. All right. So no matter which way you did it, you should end up with the same numbers here. And this is just counting from up here. So what'd you guys get for the first class? 3.
3. 2.
Good. All right. The only thing I was trying to make happen is to make a lot in the middle. I didn't know what else would happen from there as I wrote those numbers. All right. And we'll get into why that's true, why I tried to make that happen. So let me graph this. I'm going to graph it using the boundaries because if you did it this way, it's easy. You would just put 7, 15, 23. It's awesome. If you did it this way, you start at 6.5. And the nice thing is once you know where you start, you just keep adding the width. So 6.5 plus 8, 14.5, 22.5, 30.5, 38.5, 40, 6.5. All right, cool. Yes, ma'am.
Can we ever skip the percentage and just put like 2 to 10 or 0 to 10, or will you knock this down?
How do you
on
make
the side, on the left side?
when you do this here?
Yeah, can you do 2 to 10?
Whatever your scale is, it's got to be consistent. So I used the scale of 5 there.
Well,
If it makes more sense to use a scale of 10, you're fine.
Like,
Is that
instead of percentage wise, so instead of like calculating 3 out of 18 to get like 16%, can you just do 2 to 10? Can you just leave it like 2 to 10 and then just mark it as 2 to 10?
Oh, you mean here? So this is the frequency, right?
Yeah.
All right. So what's the relative frequency? How do I get that? Because I asked for. It depends on what I asked for.
Okay.
If I ask for a frequency histogram and you use percentages, that's not right. So how do I get the relative frequency here?
Divided by 17.
Yeah. So divide 3. And how many things were there? 18. So 3 divided by 18 is like 16.6. Is make it 17%. 17. 8 divided by 18. 44.4. So just make it 44%. Good. And when you add those up, you get, oh, good. And when you round, you don't have to get 100, but it's got to be close. If you get 103% or 97%, that's too far off. Something went wrong. You rounded in the wrong direction somewhere.
On your, the 7.42, you said 22, are you needing to do this by 7 or should we be doing it by 8? So it was 7.2 and you said you rounded to 8.
Yes. So this is 8. This is 8.
Oh.
This is not going to be 8 because then that would be 15, and then I would put 15 up there twice.
Okay.
So that is why this method has problems. because you can't overlap these, because then there would be two places for that data point to go. So it has to pull this back, which introduces all this idea of a boundary, so there's no gap when I go to make it visual. You guys kind of with me? And that's the kind of stuff that drives me a little crazy. And I teach this way because it's what's in the book, and I want you to be able to reference your book to help you when you do your, that's the way it's supposed to work. But I really don't like this personally because of the problems it introduces. And that's why I do it this way myself. If you want to do it that way, beautiful. You can't. It's no problem. Just do it right.
Okay.
All right. Yes?
The elements should be 12, right?
Which one?
The elements, so 11 should be, you will round it to 12. Round it to 12 because it
1/9 is 0.11111.
no, it's, I think 11.1.
Yes, it is 11.1. I love it.
So, 11.
No. So so when we got 7.2 for the width is a physical thing. Are you with me? The width is a physical thing. So if I want to cover the whole thing, I have to round up always. If I ever round down at all, I'm not going to cover it, am I? This is a number. How do you round 11.1? Good. So the only place you always round up, there's going to be a few places in this classroom. For example, if I said I have to talk to 28.3 people to be sure about something, that's going to happen to us later. I would have to round up to 29, because if you find 0.3 of a person, that's freaking me out. That's either a person or an eighth. I don't care what happened to you, you are still a person. You with me? So there are going to be a couple places in the class, in this class, where we have to always round up to make it make physical sense. This is a number. How do you round numbers? We know 5 or not. Yeah, we know how to round them. Good. I like it though. Because otherwise, then you always have this adding up to be some crazy number. So this came out to be 100, which is nice. And now, how do I make my scale? I want to be able to go all the way up to 44. So I can just go by 10, maybe 10, 20, 30, 40, 50. Man, this thing is really loaded with stuff. I think I can get my data away. All right, and then here's the easy part. Right? Just make the height the right height. This will be 3. It's about 5. 3 is barely up there. 3 again.
17.
Oh, sorry. Thank you. It's all melded together up here for me, so it's my fault. So 17, that's better. I can fit that in there.
44. That's 44.
17. Then 44. And then 11. And 11. All right, so it looks like the problem is sort of giving us the finger, but not my intention. First thing I noticed. Now, I want to ask you something. This is the last thing I'm talking about, then we'll go on our little field trip. This does not quite have a property that this one does. A very visual kind of property that some of you guys should know about. What shape is this roughly that's got something to do with statistics? I like the parabola answer. That's kind of nifty. It is kind of, you can think of it like parabolic. But in terms of statistics, it's got bell curve, what's called a normal curve. So when your teachers curve the grades, there's a lot of different ways to do it, but the most basic way to do it is to just, maybe these people made 40% on the test. That's the highest grade. Holy shit, we curved that. So you just pick up the whole and curve and you just move it over. And that's curving the grades. When I curve grades, I do it a little bit differently. I actually change the shape of it a little bit and then also move it. But one way to do it is just pick the whole damn, that's why it's called curving the grades. You pick the damn curve up and move it. You kind of with me? So what's the basic thing that tells you it's got a bell curve shape? Besides the look of it, it starts low, goes up, and it comes back. So our picture doesn't quite do that, right? This is a little too. I would say this is really roughly normal, especially because our sample size was so small. If we got more, whatever that was, and of course it was just numbers in my head, but if we took more of a sample, maybe it would be more normal, right? And the normal curve is incredibly important in statistics, and we'll actually finally learn why truly in chapter 6. But stuff like heights, I didn't know what was going to happen when I graphed this. I just took everybody's, what you put in there for your mom and dad's heights, mashed them up and graphed it. That's a normal curve. Because what's true about heights? Most people are going to be in the middle. Are there a lot of people that are really, really tall? Not like that. Yes, where I live. They're all over 7 feet. Right? And are there a lot of people that are really, really short? No, there aren't. That's why when we see somebody, we're like, whoa, whoa. We're like, whoa, we don't see that all the time because it's not normal. Right? Not that something's wrong with them, it's just not normally seen. So that's why I love that word. It's actually, it describes physical things like length, height, stuff like that. All right, so let's do this. Hopefully I don't lose too many of you. And if you can't make it, just I want to make sure you know where everything is on campus. What we're going to do is we're going to go out the door and wait for me to get in front of you. We're going to go over through the library, I think, and attack the Math Study Center first. Realize that they're afraid of noise in the tech mall. So in the library course, so just don't make